Now let's learn about the states of matter. Matter around us exists in three different states. I have been talking about it through all the time right now. And yes, these three states of matter are solid, liquid, and gas. Now, these three states of matter, they arise due to the variation in the characteristics of the particles of matter, like shape, volume, intermolecular space, etc. So, the very obvious physical quality characteristic is that solid, they have, again, like I have been telling you, they have a strong force of intermolecular attraction. So the particles are very tightly wound against each other. Whereas liquid, they have a weak force as compared to a solid, and gases, they have the weakest force. So the shape of a solid, therefore, is bound to be very firm, is bound to be very concrete because of the strong intermolecular force. Volume, intermolecular space, these are the characteristics, right? So let's learn about the states of matter. Properties of the solid state. Solids have a definite shape and fixed volumes, that is, they have negligible compressibility. Solids have a tendency to maintain their shape when subjected to outside force. Solids may break under force, but it is difficult to change their shape, so they are rigid. Examples of solid state: a pen, a book, a needle, a piece of wood, etc. So yes, solids do have definite shape because again of the strong intermolecular force, because they are tightly wounded against each other. And yes, because of the tight, the very cage-like structure, the very tightly wounded atoms, they have very strong forces. Because of this shape, they have fixed volumes. Why? Because they have a definite shape. You can ascertain, you can measure the volume of a solid very easily because it is all very cohesive, right? It is all very tightly wounded in a one solid space. So, and because owing to these qualities, they have negligible compressibility. That means if you want to compress a piece of solid, you will have to apply more force. So if you want to compress, say, this example over here, a water bottle or a diamond or a pen or this pen, right? A book, a needle, anything, you have to apply a lot of force. Why? Because of that definite shape and that fixed volume, and because you cannot compress it easily. So therefore they have negligible compressibility. Solids have a tendency to maintain their shape when subjected to outside force. So this we can easily see in an experiment, I think, which comes next. That is a rubber band. When you try to exert force in a rubber band, when you try to stretch it by your hands, so you're basically applying external force to it, right? So it will change shape, okay? But when you withdraw your hands, when you withdraw the external force, that state of matter, that rubber band, it comes back to its original shape. So solids have a tendency to maintain their shape when subjected to outside force. They may break, but it is difficult to change their shape because they are rigid. Rubber band change its shape on stretching. Is it a solid? Like I told you right now, rubber band is a solid. So when you applied your hands while stretching a rubber band, so you basically applied an external force. But when you withdrew your hand, when you withdrew that external force, the rubber band, it did come back to its original shape. So yes, the solid, that piece of solid, that piece of rubber band, it had a tendency to maintain its shape when that external force was extracted, was withdrawn. So yes, solid rubber band is a solid. Rubber band changes shape under force and regains the same shape when the force is removed. If excessive force is applied, it breaks. Now, a brainstorming question. In this question, we see that when kept in different jars, sugar or salt take the shape of the jar. Are they solid? The shape of each individual sugar or salt crystal remains fixed, whether we take it in a hand, put it in a plate, or in a jar. So yes, collectively they do take the shape of whatever jar they have been stored in. But when you take an individual grain of salt or an individual grain of sugar, and when you try to, compress it, or to, try to perform all those experiments that you do with a solid, you notice that the shape of that individual sugar or salt crystal is very fixed. It has a constant space, mass, and it has a fixed volume of its own. So yes, it is a solid. We are able to compress the sponge. Is it a solid? A sponge has minute holes in which air is trapped. When we press it, the air is expelled out and we are able to compress it. What we notice here is a sponge, even though being a solid, it has tiny small sacs of air trapped. So if this is a solid piece of sponge, like you can also see in this diagram, they have it is porous sort of, right? It has very tiny sacs in which air is trapped. So you basically, when you press it, the air is expelled out and we are able to compress it. That is why. So yes, overall a sponge is solid. Properties of the liquid state. Now we have learned the properties of solid state. Now they have a fixed shape, fixed volume, they have negligible compressibility, and they are able to maintain their shape when applied an external force. Okay, and very few solids, uh, being different in nature, when applied that external force, is able to break out of its shape. But mostly, overall, the solid is very rigid in its shape. Now let's learn about the properties of the liquid state. Liquids have no fixed shape, but they have a fixed volume. They take up the shape of the container in which they are kept. Liquids flow and change shape, so they are not rigid but can be fluid. Examples of liquid substance: oil, juices, water, etc. Now liquids have no fixed shape because in whatever container you may pour a liquid, that liquid takes the shape of that container. But liquid, it does have a fixed volume. Liquids do have fixed volume. And liquids flow and they change shape. So they are not rigid, but they can be called fluid. Why can they be called fluid? Because they have the ability to flow. Substances that have the ability to flow, that have the ability to change their shape, and they are not rigid, those are fluid. And therefore we include that liquids such as oil, juices, water, all these are fluid substances. Why diffusion of gases into liquid is important. Now this is a very important phenomenon that happens and it is very crucial for the biodiversity. Let's find out. The gases from the atmosphere diffuse and dissolve in water. These gases, especially oxygen and carbon dioxide, are essential for the survival of aquatic animals and plants. All living creatures need to breathe air for survival. The aquatic animals can breathe underwater due to the presence of dissolved oxygen in water. Thus, we may conclude that solids, liquids, and gases can diffuse into liquids, and the rate of diffusion of liquids is higher than that of solids. Now, let's simplify what this is saying. The gases from the atmosphere diffuse and dissolve in water. Yes. Now, in a water body, say a pond or a lake, or large water bodies such as rivers, oceans, you know that fishes and aquatic animals live inside. Now, how do they breathe? They breathe because gases such as oxygen and carbon dioxide, they are dissolved in water. So this is a very natural phenomenon that keeps happening. That air has oxygen and air has carbon dioxide, right? And any water body, okay, any water body, what happens that air from the atmosphere, gases from the atmosphere such as oxygen, carbon dioxide, and even nitrogen, they dissolve in water. Okay, they dissolve in water, and aquatic animals and even aquatic plants, they breathe in these dissolved oxygen or carbon dioxide, and that is how they're able to survive. Because as you know that all living creatures need to breathe for survival. The aquatic animals can breathe underwater due to the presence of dissolved oxygen. Now, we may conclude that solids, liquids, and gas, all the three states of matter, can diffuse into liquids. Now, we had seen in that early experiment that you were dissolving salt or sugar granules, which are solids. You were dissolving that in liquid, right? So, solids can dissolve in liquid? Yes. Liquids can dissolve in liquids? Yes. When you mix two types of liquids, like, say water and say, any other oil like juice. Okay, when you dissolve water and juice and you mix it, they do dissolve, right? And gases, like we have just seen here, that air and atmospheric gases like oxygen and carbon dioxide, nitrogen, and many other gases, they keep on dissolving in water, they keep on dissolving in liquid, and the rate of diffusion of liquids is higher than that of solids. Why the rate of diffusion of liquids is higher than that of solids? Now I've just answered it for you. It is because particles, they do have the tendency to intermix with each other, and the rate at which different particles such as solid, liquid and gas, I'm sorry, the rate at which they keep dissolving in liquids is higher than that of solids, because liquids, they have intermolecular spaces in between them larger as compared to solids, and because of that large intermolecular spaces, small solid substances or even liquids or even gases, they're able to get in between those spaces and they're able to dissolve. Whereas solids, owing to their tightly bounded and the high rate of attraction that the molecules have, because of that strong bond, the rate of diffusion in solids is low. This is due to the fact that in the liquid state, particles move freely, yes, have greater space, yes, like I told you, as compared to particles in the solid state. Properties of the gaseous state. We found out about the liquid state, that they have the high rate of diffusion, and they have the interatomic and the intermolecular space is less as compared to the solid, and they have lots of space in between the particles. Now let's study about the gaseous state. Gases have neither fixed shape nor fixed volume. Now solids, they had fixed shape and fixed volume. Liquids had no fixed shape but they had fixed volume. Gases have neither of these. They have neither fixed shape nor fixed volume. They occupy the shape and volume of the container in which they are filled. Gases are highly compressible as compared to solids and liquids. Gases also have property to flow, so known as fluids. Now, like I had told you before, fluids are the matter, substances are named fluids. Those substances are named fluids which have the property to flow. Now, liquid, it can flow, and gases also, since they have no fixed shape, no fixed volume, so gases, like air, we breathe in oxygen from the atmosphere, right? So all around us, air is, they have no fixed shape, they have no fixed volume, and it is continuously in motion, right? So it has the property to flow. So gases are also fluids. Gases and liquids are fluids. Solid is not a fluid, but gases are highly compressible as compared to solids and liquids. Why? Because the intermolecular and the interatomic spaces between the gases is very high. And why is it high? Because the intermolecular attraction between these particles is very low. So the space is high, and whereas the force of attraction is low. Okay, so because of this, gases can be compressed. And the example of gaseous state substance, oxygen, gases from volcanoes, etc. Activity. Now let's look at a fun activity. Let's look at the compressibility of matter. For this, we'll be taking 300 milliliter of syringes and we'll be closing the nozzles by rubber corks. So you have to be very careful while performing this experiment. You have to take out the needle and you have to close the nozzle by a rubber cork. Done. And then you have to remove the piston. So the top lever sort of substance through which you push and you pull through a syringe, that is known as a piston. So you have to remove the pistons from the syringes, leaving just one syringe untouched. Now fill the water in the second one and the pieces of chalk in the third. So what we have done is we have left one syringe as it was, we have filled the other one with water, and we have filled the third one with pieces of chalk. And after doing all this, now we have again inserted the piston that we had removed earlier, and now we'll begin try to compressing the content by pushing the piston in each syringe. What do we observe? In case of air, the piston of the syringe is more compressed. Okay. In case of water, slightly compressible, whereas in case of chalk, it is not compressible. Now, as I have been time and again reminding you between the particles of matter, that how about the intermolecular spaces and their forces of attraction, because of that, the air is the most compressible. So that is the most easy. That was the most easy one. The piston of that syringe was the most easy one to push. whereas water was, slightly more easier than what it was to push through chalk pieces, because chalk was not at all compressible, chalk being solids. From this we can conclude what we had been determining earlier, that gases are highly compressible as compared to solids and liquids. Now, a brainstorming question. We come to know of what is being cooked in the kitchen without even entering there by the smell that reaches our nostrils. How does the smell reach us? The particles of the aroma of food mixed with the particles of air spread from the kitchen reach us and even farther away. Due to high speed of particles and large space between them, gases show the property of diffusing very fast into other gases. This we have already seen earlier in the incense stick experiment, that when we had burned the stick, the aroma particles of that incense stick was easier and very quickly, diffused into the particles of matter of the air, and that is why you were able to smell it even when you were sitting across in that room or in your classroom or anywhere. Same goes with the food, like we had seen in that cold food and hot food experiment question. I'm sorry. Aroma of hot food, it mixes very easily with the air and reaches us even though we are farther away, because of the same quality of gases. That gases, they have the property of diffusing very fastly into other gases, and this property is this property increases as we increase the temperature. So if we are trying to smell the aroma of hot food, it can be smelled from far away as compared to the aroma of cold food, like we had seen earlier. How gases exert pressure on walls of container. Now, in the gaseous state, the particles move about randomly at high speed. Due to this random movement, the particles hit each other and also the walls of the container. The pressure exerted by the gas is because of this force exerted by gas particles per unit area on the walls of the container. Now, we do know from an early experiment that particles, they have some energy, that is and that energy prompts them to move, to be continuously moving, the kinetic energy, right? We had seen that this in the experiment where we had added inks, droplets of ink in water, and that had dissolved on its own without applying any outside pressure, like without stirring from the outside. Similarly, now gaseous state. Now, since the particles of gases are very far away from each other, so what happens is that because of the less intermolecular attraction between them, they are constantly trying to pull away from each other. So solids, they are very tightly wounded against each other, whereas gases, they are very far apart from each other. Okay, so because of this huge distance, the particles, they try to move away from each other because the force of attraction is not that strong, and because they're trying to constantly move away, so the energy which they contain, that the kinetic energy, is higher in gases as compared to any other state of matter. Why? Because of the low molecular intermolecular attraction. So because of this high energy, the particles of gases, they do tend to be in a random continuous movement, and they hit against each other and also against the walls of a container, any container. In this picture you can see a balloon, and you may see that whatever air particles are there in this balloon, they are very far away from each other, and they are in a continuous state of a movement, and they're in a continuous state of exerting pressure towards the outside, towards the container. The pressure exerted by the gas is because of this force exerted by gas particles per unit area on the walls of the container. Question. The mass per unit volume of a substance is called density. Density is equal to mass by volume. Arrange the following in order of increasing density. Now, we do know mass, we do know volume. What is density? So density is basically mass by volume. We determine density by D, we determine mass by, let's say, M, and we are determining volume by, let's say, V. So density is equal to mass by volume. That means the higher the mass of a particular substance, the higher is its density, whereas the lower the volume of a particular substance, the higher the density, but the higher the volume of a particular substance, the lower the density. High, because density is inversely proportional to volume, and density is directly proportional to mass. So we have been given a list of substances. Now let's arrange them in the order of increasing density. That means from low density to the high density. Air, exhaust from chimney, honey, water, chalk, cotton and iron. The first in this would be air, because air is all around us, right? Air has all types of gases, and all these gases are in a constant state of movement against each other and also with each other, right? So air, also the density of air is it's the least, okay, among all of these. So air has the lowest density. Moving on, the exhaust from chimneys. Now the exhaust from chimneys, they are not as widely spread, they are not as widely scattered as compared to the air in our surroundings. Also, the exhaust from chimneys, they may have numerous gaseous particles, numerous gaseous, um, particulates in that, right? That is because exhaust from chimneys, they may be coming from, say, a kitchen, they may be coming from, say, an industrial power plant. So we know that it can have a lot of hazardous gaseous particles as well. So these particles will be definitely be heavier than air, because air is what you feel around us. It's light, right? It's continuously flowing. But this exhaust is coming from, from a particular chimney. It's coming from already, say, a high pressure. So these gases, they have higher density as compared to air. Honey, water, chalk, cotton and iron. So this is a tricky one. You may be thinking that honey would come next, and then water, since both of these are liquids, and then maybe cotton and chalk and iron. But no, the next material which will be coming next is cotton, and this is because cotton, just like sponge that we had seen earlier, cotton, though it is a solid, it has lots of air sacs. It is porous, just like a sponge, right? So it has tiny air sacs, and since these have tiny air sacs, so a lot of gaseous particles are there in between the, say, the tightly wounded or slightly tightly wounded cotton particles. Because of this, cotton will be coming next. Furthermore, we'll be seeing that honey would be coming next. And why would honey be coming next? Because honey, it has, you know, the density of honey is more than the density of water, because you must have noticed in that early experiment that honey is heavier. It took more time to dissolve in water because of its heaviness. So honey has more density than water, and then there is just two items left now, that is chalk and iron. So definitely chalk has lesser density than a solid piece of iron, which is very, it's very hard to break a piece of iron. Next question. Tabulate the differences in the characteristics of states of matter. Now we have been doing this all along while reading it, right? Now states of matter, the most obvious differences in the states of matter is that solids, they have the intermolecular spaces in a solid is less, whereas the intermolecular attraction is higher. In liquid, the intermolecular space is higher as compared to solid, lesser as compared to gaseous, but the force of attraction is less as compared to solid and higher as compared to liquid. Gases have the least intermolecular force of attraction because the intermolecular spaces between the gases is the highest. Comment upon the following: rigidity, compressibility, fluidity, filling a gas container, shape, kinetic energy and density. Now rigidity is the tendency of a particular object to maintain its shape. So solid, it has high rigidity because it has a fixed volume and a fixed mass, if you may remember from the earlier lesson. Liquids, they are not as rigid as solid. Why? Because liquids have no definite mass, but they do have a definite volume. So they're not so dense, they're not so rigid as a solid, but yes, they do have some slight amount of rigidity. Whereas gases, they have, I don't think they have any rigidity at all, because gases neither have fixed mass nor do they have fixed volume. Compressibility. Compressibility depends on the amount of, the intermolecular attraction as well as space. So solid, it is very hard to compress a solid because again the space is higher, space is less, I'm sorry, and the attraction is higher. It is more easy to compress a liquid and it's the easiest to compress gas. Fluidity is the ability to flow, and we have already seen that gases and liquids, both of these, they have the ability to flow. So yes, filling a gas container. Filling a gas container requires high amount of pressure, and the gas is, compressed into that container owing to the amount of pressure that it exerts and owing to its, negligible rigidity and its high amount of compressibility. Because it has no mass and it has no fixed volume, that is why a gas can be easily compressed into a container. Shape. Solids have a definite shape. Liquids do not have a definite shape because they, can, its shape can change from container to container, and the same goes for gas. Kinetic energy. Now, owing to the large intermolecular attraction, the solids have less kinetic energy than gases, than liquid, and gases, they have the highest amount of kinetic energy. Why? Again, owing to the large intermolecular space and the low intermolecular attraction. Now, density, as you may remember from the previous question, density is mass by volume. So yes, solids are dense. Liquids, they do have, the liquids are dense but not as dense as compared to a solid, and air is not, like compared to solids and liquids, air is the least dense substance. Let's move to the third question. You have to give reasons. A is a gas fills completely the vessel in which it is kept. Yes, because gases have a high amount of compressibility and they can be easily pushed into a vessel. A gas exerts pressure on the walls of a container. Yes, because like we had seen in that balloon and the container thing, that gases have high amounts of kinetic energy owing to the low amount of intermolecular force of attraction. So gases, they do exert pressure on the walls of the container. Then a wooden table should be called a solid. Absolutely, because solid, anything is solid that has a fixed mass and a fixed volume. So wooden table is solid, it has all the characteristics of solid, it is not compressible and it is harder to break it. So wooden table is definitely a solid. We can easily move our hand in the air, but to do the same through a solid block of wood, we need a karate expert. Now this is very easy. See, I can move my hand through the air, right? This is because, like I said, a diver can, it's the same thing, right? The diver can break through water, surface of water, because the intermolecular force of attraction is not as high in gases as compared to a solid block of wood. So you can easily move your hand in air, but through a solid block of wood, you would not be able to move it. You will have to break it, and for that, yes, we need a karate expert. Question 4. Liquids generally have lower density as compared to solids, but you must have observed that ice floats on water. Find out why. Now this, like I have been telling you, that not all the substances of matter, even though they are in one particular state, not all of them perform, not all of them have the same characteristic. This is owing to the brilliance of nature. So, though ice is solid, okay, and the water is definitely liquid, but ice floats on water because the density of ice is lower than water. And this is because when water freezes, so water has fixed volume, right? So when water freezes, so a sort of a cage substance is formed. That cage sort of substance is the ice. So ice, they do tend to have that cage like structure, but the volume that ice tend to have after they have been frozen from water, that volume of ice is higher than the particular amount of water, than the volume that the particular amount of water had. Okay, so because of the high amount of volume, like I told you that density is inversely proportional to volume, because of the high amount of volume that a certain quantity of ice has as compared to the respective amount of water, the density of ice is bound to be lower than that respective amount of water. Are you getting me? That is why you see that ice, they are floating on water, even though ice is solid and water is liquid, owing to the density, and owing density again owing to the respective volume that a certain amount of ice has. The high density, the high volume that the ice has.